All right, so what we're going to do here is we are going to look at neutralizing acids and bases. So I am going to start by stopping. All right, we are going to look at neutralizing acids and bases. Now, I'm sorry this isn't as head-on as we are used to it being. I left my phone at home, and so I have to record this with my laptop. So first thing we're going to do is we're going to fill 2 of these wells with some universal indicator solution. Now this first well, this one right here, is going to be our control. So we're not going to do anything with that. So the first thing we're going to do is I have some citric acid solution here, as you can see. And I'm going to put in 3 drops of this citric acid solution into this well. 1, 2, 3. So let's stir that with a toothpick here and see. Ooh, it turns pretty red. Let me get my my acid base chart. And looks like I'm at a pH of about 2. So look at that, maybe 2.5, 3, somewhere around there. Okay. So now I have a sodium carbonate solution, and I'm going to see how many drops of sodium carbonate it's going to take to neutralize this and turn it back to that same lovely green that we had there. So I'm just going to add it 1 drop at a time. So 1. And I'm going to stir every time. Oh, wow. That made it blue. It was actually more than what we needed. Let's see. I can maybe do like a half of the drop. Oh, wait. Look. Look, it turned green. Oh, that's so cool. All right, so it took 1 drop. 1 drop of my sodium carbonate solution neutralized my citric acid. I just needed to be patient and wait for the reaction to occur. All right, so now I am going to add some more citric acid to my citric acid solution and make it more concentrated. I'm going to add 1 scoop and 2 scoops. Okay, so I've added a little bit more. I've made it a little bit more concentrated, and I'm going to swirl it. And I'm going to put it in this well right here, and I'm going to do 3 drops. And I'm going to do 3 drops so that we have the same number of drops that we had last time. Okay, so I'm going to count 1, 2, 3. Now, it has more citric acid, but it doesn't have any more water. So it should be a more concentrated solution. So let's see. Woo, it's definitely more acidic. Woo, check that out. We've got a pH of like 1. You can't actually have a pH of 0. I hate this chart. But we have a pH of about 1 there. All right, so let's count and see how many sodium carbonate drops we need to add. Now we learned the last time that we need to wait a little minute for it to balance out. So I'm going to add 1. I'm going to stir and I'm going to wait and just see. Well, that didn't even, like that last one went blue. This one is yellow, so I'm going to keep going. So there's 1 drop. There's 2 drops. Still yellow. There's 3 drops. Oh, we're perfectly green, but I'm going to wait a minute and just see what happens with that reaction. Oh, see, it's turning more yellow. Do you see that? So I'm going to add a 4th drop. Stir it up. Now we're kind of blue, but we're going to wait. Wait. And we're going back to being more green. So this one took 4 drops to neutralize it. All right, we're going to skip over to the next activity. I'm going to put 3 wells of universal indicator again. And I'm doing 3 because one of them is going to be my control and 2 of them are going to be for the experiment. Okay. And I have 2 solutions here. I have solution A. Oh, that's solution B. Solution B and solution A. Okay. And I'm going to put the same number of drops in each one. I am going to put in, I believe, 3 drops. Yep. Oh, 2. 2 drops of each solution. So this one's going to be solution A. It's going to have 1, 2. 2 drops of solution A. And let's get a clean toothpick. Stir around solution A. Ooh, that's a lovely shade of blue. And then right here, I'm going to have 2 drops. 1, 2 of solution B. I'm going to stir that one around. Okay, ooh, okay, so let's pause for a moment and let's look at the pH of each of these. Let's wait for a second for it to even out there, for everything to react. I noticed that the solution B one is getting ever so slightly more purple. So let's look at these pHs. So it looks like solution A has a concentration, it's about a pH of about 9, and solution B looks like it's about 11. So I've got my citric acid solution, and it's not, I just diluted it. So it's not the super concentrated citric acid solution that we had from the last experiment, okay? So we are going to count and see how many drops it takes to neutralize each one. So I'm going to start with 1. Always start with 1. 1 drop. Ooh, that went very, very pink. Let's pause and see if it backs up. We might need to dilute our citric acid solution a little bit more and redo this experiment. Okay, I diluted it quite a bit more. I'm going to put more universal indicator solution right here. Okay, with 2 drops of solution A. Because our citric acid solution was just way too strong. So 2 drops of solution A. Let's get a clean toothpick, stir this all up with. I have like a pile of toothpicks over here. And looks like we're at about the same pH that we were before. Okay, we're at about a pH of 9. Okay. So my citric acid solution is now way more dilute, so we can get some good numbers here. Okay. So if I have 1 drop of citric acid, what does that do for us? A little bit. Let's do a second drop. 2. A little bit. Oh, 2 is too many. Oh wait, it's backing up and it's turning a little bit more green. Okay. So it took about 2 drops to neutralize solution A, and we even went past it a little bit. Let's look at solution B. 1 drop. Stir that up. Still blue. 2 drops. Stir that up. Still blue. 3 drops. Stir that up. Oh, and we went a little too far again. So it took 2 drops for this one, and it took a little bit less than 3 drops. A little bit less than 2 drops, probably 1.5, and probably 2.5. But we got them to about the same color, actually. So there you have it. Those are the neutralizing acids and bases. And we went a little bit too far. If I could have done a half a drop, that would have probably worked a little bit better for these 2, but we can still use the numbers that it took. 3 or 2 on solution A and 3 on solution B.